Hello and welcome back to the messy desk. So I've made probably 5 steps forward, 10 steps back maybe on getting some data out of this. What I did find that was interesting is if I turn it on with that chip select pin tied high, it goes into this interesting sort of debug mode, and I'm looking, we'll do that again with the scope on. So there it's off. Turn it on. This is the output line. This is the input line. So that you got that pulse that we saw yesterday. Input has now floated high. If we tie that input low, let's see, we get a response on the output line, which sort of gave me some ideas about what might be going on here, and I thought I'd make some progress. So I found my little FTDI serial port guy, hooked it up, got Minicom running on my Mac, and tried sending serial data through, and I couldn't get much. In fact, I couldn't get anything, to be honest. It's interesting is whenever it boots up into this sort of weird debug mode, I assume that's what this is. The top number is always 40, the bottom number is 10, and this number seems to vary between I've seen it as low as 24. This is the highest I've seen it. Usually it's like in the 50s. I'm not sure what it means. I've had no success in sort of varying it, but it sent me down a very long path, and I spent a couple of hours just trying to get serial working, and I couldn't. But while I was looking for that serial adapter, I found my JTAG adapter. I found my first one, which was just something I bodged together on a parallel port. But then I found this one, which actually is only one dongle away from plugging into the Mac. But I haven't actually looked at the JTAG yet. I went down a few other paths that I'll share with you now. The first path I went down was just trying to get the analog signal off of the pressure sensor. I was so frustrated with the serial signal. I thought, you know what, why don't I just build this myself, pull the motor out, pull the solenoid out. Then the only part I'd really have to work out is how this pressure sensor works. I spent some time trying to find a data sheet, trying to identify the part. I think it's like a Wheatstone bridge, where you have you know what a Wheatstone bridge is, maybe. And I thought that if I could get the signal from these two ends of it, I'd be able to sort of read it out, but I couldn't. I don't know, I was doing something wrong. So I didn't get much luck there. But then I started browsing down this bottom section of the board, these chips here. I sort of ignored that when I was first looking at the PCB, because I saw this is where the power was coming in. I saw some power caps, I saw some things with heat sinks, and I figured this is all just the power section. I don't know how close I can zoom in. Let's test the limits of iPhone zoom. Oh wow, it's actually way better than my eyesight. I should have done this before. But that chip, ooh, my finger is huge. Where are you? It's my knuckle. Anyway, there. Focus. That's an I2C EEPROM chip. I don't know what this one is. I couldn't read it with my naked eye, but I've got a good photo of it now, so I'll look at this photo once I've got the video. But that's I2C EEPROM. Let me find if I can find a better pointing device than my finger. Most of the pins on this are actually unused according to the data sheet, but you have SDA and SDL there, which are the I2C data lines, and they're broken out to 2 pads there by the looks of it. So I'm going to solder onto these guys and test out the I2C decode of my fancy new scope and see if we can get some data off it. I think we're getting closer. Alright, I'll set you aside and do some soldering. Set you aside. I'll move the camera aside. I'll never set you aside. Alright, let's turn the power off. And I can't wait to be in my bigger shop where I can just have a big messy table. Alright, that gives me a great view on the camera, but I don't know if I'm going to have enough room to reach my arms around to solder, but I have soldered in worse conditions. Let's move this guy out of the way. I really need to clean that tip. Oh, I've turned the soldering iron off. That's probably why it's not as hot as it should be. I'm not sure if you can hear that, but we have a baby lamb right outside this room. Also 2 baby goats, but the lamb is the one you can hear. He's a loud boy. I had to manually pull him from his mother during delivery because he was quite large. He was a 15-pound lamb, which is large for a lamb. So Mama needed some manual assistance, but I got him out, which was good. Unfortunately, Mama didn't do so well and was not able to breastfeed him. Well, yeah, I still call it breastfeeding. So we've been feeding him by hand while Mama's gotten better, and Mama has gotten a lot better, but the boy just prefers being bottle fed. So we have a large bottle fed lamb outside this room. What did I say yesterday? That I'd be jinxing myself if I said this was going to be easy, and I kind of did. But I've got a good feeling about this. Let's see how this ends up. All right. Oh, yay! Well, got an error there, but what you missed on the scope was data. I don't know why we errored out, but that's a problem for another day. Alright, we're in rolling mode. It would be better to... I'll just show you it here. And then I can do a better capture of the I2C data. Oh, there it goes. Did I actually... No, one sec. Did I actually save that? Sorry, I'm new to having a digital storage scope. I may not have actually saved that. But I did get a blood pressure reading. Now, it did throw the same error on that screen, the EE3 error. But I wonder if EE means electronic EEPROM. I'm erroring out because I've changed the signal integrity of those pins. But it was still trying to store my blood pressure in the RAM, in the ROM. So that's a very good sign. There it goes. Look at that. I can look at the history. Alright. Can I decode from memory? Let's have a look. Let's try the decode button, which is over here. Decode. No, I guess I can't. I have to be probably in that mode. Y time base. Alright, decode. I2C. Sources. Channel 1, channel 2. I think that's the right. Sources. Bus status, turn it on. Zoom out a bit and store more memory. Alright, anyway, let's try this again. Take my blood pressure. You'd be happy to know that over the course of videoing today, my blood pressure is much lower. My trigger level's good. Yeah, I can trigger up here. Trigger is on channel 1, rising edge. Should be coming any moment. Alright. I guess it went right by. Hey kitty, yeah. I'm going to keep on noodling with this and see what I can get. Be back in a sec. I'm going to learn how to use this scope a bit better. Alright, I've got it set up to capture a single rather than to keep on running. I think I've got everything set up so that it should capture all the packets going back and forth. I've never actually used the decode function on this scope yet for anything real, so actually I've never used it on the scope before. My only other scope, other scopes have been analog, so this is an interesting learning experience. A sound. Oh yeah, look at that. I was so excited by looking at the scope I didn't look and see what my blood pressure was. Yeah, look at that. Wow. AC1, I assume AC1 is good. Read 19, write 66. Read, write, read, write. Read, write. Event table, I guess. Alright, how do I see the address? How do I see the data? Payload? Details. Huh. This is really, really cool. This is way better than an analog scope. Yeah, okay. Can I export? I'm going to go back to the decode button. I squared C. What's without? With? I don't know. Display event table. On. Okay, there we can. Oh, okay. I guess the event table is just showing what's on the screen, so I have to zoom out to see everything. All right. Okay. Not seeing any data in there, but export. Save. Let me go find myself a thumb drive. I've got to have one of those around here somewhere. Okay, so it's a couple of hours later. I think I've worked out how to read the data with this scope. What was throwing me off is I had the trigger set up and I thought there was only one packet of data all the way up the front here. So I kept on exporting this data. Where'd you go? And going, hey, there's nothing here that looks interesting. It's hard to see on the screen, but I was loading it up into R and I took a bunch of samples. And I'm like, I can't find any correlation between this data here and the blood pressure readings. So I don't know how, but I stumbled across the fact that I was zoomed in too far. There are more data packets that follow, which makes a lot more sense. So if we go have a look at the event table, we're starting to see the data in here now. So I've taken a bunch of samples of this from a few different measurements, and I'll load them up onto the computer and do some clickety-clack on the keyboard, and I think I'll have cracked this nut, and I feel good. Yeah. I was looking back at the video and I said when I started that, I was hoping I could find like a memory chip that was attached to a known micro and I could just read off the memory chip, and that's what I've done. I went down a bit of a garden path with that other serial port and then trying to read directly from the sensor. This seems to be doing exactly what I want, which is giving me the data in a nice digital form, over I squared C. So I'll decode this, hook it up to an Arduino, and continue on with the project. See ya.